But Peter, again, going and looking at your stand, coming to your press launch, you said many things there, and you are renowned in the industry for being at the real leading edge, the pinnacle of this engineering in and around the electric vehicle proposition now. You know, you've got a wealth of experience, not just in what you're doing now, but certainly in many companies before, arguably most notably Tesla. But you talked about race-derived technology. Can you kind of expand on that a little bit?
Yeah, I think a lot has been said about technology being transferred from the racetrack to the road car. And I spent most of my life in advanced engineering. I've not seen much of that until now, very refreshingly. LUCID was the sole supplier of batteries for Formula E through the Generation 2 era, where we really transformed the sport. We supplied a battery which would enable a full race distance without the need for stopping halfway. And that made for a much more coherent, cohesive motorsport. And the great paradox was the sport was really conceived to exemplify the prowess of electrification. Until it had the right battery, it actually demonstrated the limitations of the other technology. And we learned so much there, particularly about thermal management of battery systems. And we've really been able to genuinely transfer that technology and that know-how and those chops, those technological chops, into every Lucid we've got. And the way we were able to control the thermals, we're actually able to reduce the resistance inside the battery pack. So it preconditioned at the beginning of the race, and we'd allow it to gradually heat up at the end of the race within the bandwidth of what was allowable for that battery. And that way we could get away with a smaller cooling system and less drag aerodynamic on the race car. And we've actually endowed our road cars with less resistance from that learning from the racetracks of the world. And that literally has race-derived battery technology in every Lucid road car any of our customers drive.
Great. Well, and that's going to have a nice connection to the conversation we had with the Formula E team later. And again, I want to put you on the spot. My job is to put you all on the spot, but don't be nervous. I know you've had a declared ambition for some time, Peter, to get to 5 miles a kilowatt hour. Forgive me for not translating that to
That's correct.
kilometers.
Yeah.
Are you there yet? Are you close to that?
Well, Lucid Air, and this is with the EPA standard, which is the more stringent US standard. This is very important. This is what's going to have a profound impact on saving the planet, because not all EVs are born equal. There's this perception that all EVs are good because there's no exhaust emissions, all gasoline is bad, and that's not true. There's a hierarchy of EVs, and some are sort of electron guzzling EVs, and they're not very good in that respect in terms of the energy they consume. And because of that, you need a bigger battery pack. So it's really important we go for as many miles as possible with as small a battery as possible. That's what Lucid's all about. That's my mission in life.
Sure.
We get to 4.74 with the pure rear-wheel drive. That's miles per kilowatt hour. But the standard's actually been made more stringent, and that's why we're seeing all the ranges of the cars getting less in the US. Not because anyone's been cheating, but because the EPA has changed its test procedure, made it more stringent, so it's more difficult to get the range. So we're at 474 now with a large luxury car like Air. We think we could get to 5 in a year or two. The real vision is to get 6 miles per kilowatt hour. That's approximately 10 kilometers per kilowatt hour. And I really think that is the holy grail that we should all be shooting for.
Yeah. Peter, you know a thing or two about batteries. Tell me I've got this assumption right. Bidirectional charging is chemistry agnostic. It doesn't sit best in a particular LFP or NMC or something, is that correct?
Well, the rate of charging is dependent on chemistry, but for bidirectionality, the sort of rates you're looking at, it's pretty chemistry agnostic, yeah.
And the protocol, the CHAdeMO protocol, was from the utility company, not from the automotive companies, which is where CCS and NACS has come from. I hope I'm not being too jargonistic. They're just the way in which you plug it in and stuff. But am I right in saying that we're now at that point where there's almost like a dawn, there's an awakening. It's a bit like, hang on a sec, the battery isn't now this thing that we hear in the press and the media a lot, this bloody great big liability. This thing now is an asset. Yeah. It's an opportunity. Yes. Am I right? Is Luca and everyone else right, or are we getting carried away?
No, every Lucid is endowed with two-way charging, V to G, through our Wonderbox system. It's run at 21 kilowatts here with three-phase for Europe. And I see a huge... If you link that with big data, how it can really contribute to the whole grid of a nation state, because it can actually be used to balance out the draw on energy generation on a 24-hour cycle. And there are lots of other applications. There's for business use, it can do what's called peak shaving, so it can actually cut the peak periods of energy usage from the grid for a company, so you can actually put chargers in your car park, and when you need the energy back into the building, at maybe 2 o'clock in the afternoon when all the dynos are running and all the labs are on full chat, you can draw back from the cars. And a really good analogy is I'm from Wales, and there's a power station in North Wales, Dinorwig.
Oh yes.
And there's a lake on the hill, and the lake is a source of potential energy, and it powers the power station at the bottom of the hill, and when there's surplus energy on the grid, it pumps the water up the hill. So there's this potential energy of water up a hill, and that's a way of thinking of the potential energy, the electrical energy that can be stored in tens of thousands of electric cars, which can contribute to the grid at appropriate time.
And let's not lose sight of the fact that what we shouldn't be doing is transferring one challenge or problem into another one. So if we're making batteries more locally, we're getting the minerals more on the continent, and we're not moving things all around the planet, that's got to be a good move. But Peter, just as we're getting towards wrapping up, you were nodding furiously when we were talking there about some of that stuff. Do you want to add something?
Well, yes, it resonates. I think that the key here is big data and algorithmic solutions for how we use that, as Luca said, this great reserve of energy, this nascent reserve, and use it to balance the grid. There's a lot of naysayers who are concerned about the extra pull on the grid. We can turn this on its head, judo style, and actually help the grid with the contribution of the cars. And the other thing is, this is what's also very important. If we can use the tech for the cars to go further with less batteries, it means less mining of these minerals in the first place. And this is, right through from mining the minerals to application with the customer, with the electric car, a much more efficient mindset.
시청해주셔서 감사드리고 구독, 좋아요, 알람 설정 부탁드리겠습니다. 감사합니다.